it. Ignore this. And we're not going to fill in this table, okay? We're just going to make a graph. All right, guys, first thing we're going to do is just graph the sine function. Parent graph for sine. So it's been almost a week, but let's see. Do you remember how to graph the parent graph for sine? Yes? What would my labels on my x-axis be? Okay. I'm going to go to the left, too, just, you know, for fun. And then up to 1, down to -1, right? Sine starts at 0, 0. Are you guys getting faster?
Yes.
Good. Okay. Make sure everybody's here. We're now going to turn our sine graph into cosine. Kind of. So cosine is the reciprocal of sine, right? So let's think about some values here. What's the reciprocal of 0?
0.
No, yes! The reciprocal of 0 is not 0. Realize 0 is really 0 over 1, so the reciprocal of that would be... Oh, yeah, that's no good. Okay. So, what do you think shows up on a graph if it's undefined? An asymptote. Lots of answers. I like it. An asymptote. So I'm going to draw an asymptote here. Yes, asymptotes are here. So everywhere that it was 0, hopefully you draw straighter than I do today. There's an asymptote. Right? Because every time we flip 0, it's undefined.
Oh gosh.
Okay. Hectic, yeah. It's exciting.
Oh, I didn't even do the asymptotes in the right spot.
Oh no! You need some whiteout?
Yeah, do you have some?
That's like,
So you know what this is like Erica has some.
I feel like I've heard of that before. It's easily scared of like,
All right, we'll wait for the whiting out and we'll continue.
scared of letters. No.
All right, now draw them in the right way.
That explains a lot.
And guys, you may want to color code things so you can see what the actual final graph is. Like all the blue stuff is the actual answers. Okay.
Great.
All right, so let's think about flipping some other values. This is 1. What do I get when I do the reciprocal of 1?
Negative.
1. Oh my goodness. Okay, guys. 1 is 1 over 1, right? So when I flip it, it's 1. It's still 1. Do not make this harder than it is.
Gosh.
It's definitely not a half. It's not negative. So that means this point is going to be the same. Okay? The one way over here on the left will also still just be 1. All right, guys, let's try again. -1. When I do the reciprocal of -1.
-1.
Okay, you got there. Yes, that's still going to be -1. Okay. So we could go in here and do the reciprocals of 1/2 and √2 over 2 and √3 over 2, but I mean, a half is easy. The others are kind of ugly. So let's just think generally. If I'm taking the reciprocal of something smaller than 1, what happens when I do the reciprocal of
It
that?
gets bigger.
It gets bigger than 1. So that means this is coming up here. This is going down here. You don't have to plot the rest of the points. You just have to kind of draw the general shape. It kind of looks like little parabolas all over the place.
Oh my gosh, worst nightmare.
Your worst nightmare.
Seriously, your worst nightmare. Not some good reason. Parabola.
What? That's the relationship between sine and cosecant. They're reciprocals. Remember, sine was opposite over hypotenuse, and cosecant was hypotenuse over opposite. You're taking the output and multiplying that. Remember, the input is the radian, and the output is the y value. We're flipping those y values. Yeah, sine's always between -1 and 1, you know, without any sort of amplitude change. Cosecant is bigger than 1 or less than 1. Yeah. Okay, how do we feel about that graph? So the blue, so the blue graph is the actual cosecant graph, okay? When you are graphing, as a here, phone's away. Thank you. I would highly recommend you do everything as if it's a sine graph, and then your very last step is to turn it into a cosecant graph. Because you guys are good with changing the period, shifting left or right, shifting up or down, amplitude change, all of that with a sine graph, right? Okay, so to graph cosecant, you can just do all of those things, and then at the very end, turn it into cosecant. Okay, so it's not that much. Something to recognize, do you see how it's from the maximum of sine that we then go up, and it's from the minimum of sine that we go down, and it's these midline points, those are where the asymptotes come from. So if I shift the graph up or down, all of those things are still true. So even if the midline moves off of the x-axis, that's still where you're going to find your asymptotes. Okay. Let's talk about period range domain. We're going to go from the bottom up. What do you think the period is for cosecant? So if it's pi, that means this would repeat over and over. It's 2 pi, because you need an up and a down, okay? So both of those cover the whole graph. So it is just like sine, the period is 2 pi over b. All right, the range is not that bad. Look at the blue graph, go from the bottom to the top. Okay, included, right? And then, okay, very technical. We okay with that? Domain is, yes, there's a reason we saved domain for the end. Okay, there's some notation you guys have to learn. Technical terms, squiggly bracket.
Is that actually what it's called?
Can you draw that figure on that side?
One of those. It kind of ran into my graph, so.
Yeah.
All right, x. That line means such that, oh, good, good. X is an element of the reals, comma. X cannot equal. You got to figure out what x cannot equal.
Pi or 2 pi.
What about 3 pi?
Any pi.
Any pi, okay? We have to have like a mathy way to say that. So the easiest thing to do so that you're consistent is tell me where one asymptote is. Like I would call this your first asymptote. Where is that? 0. So we know it can't be 0, right? And then plus, what is the distance between asymptotes? Pi. So plus pi k. The k represents integers. I don't like how I wrote that. So it's saying every positive or negative pi from there. Now, since we started at 0, could we have just said pi k? Yes. Okay, but if you want to be consistent when these things change, it's always good to have where an asymptote is and how far apart are the asymptotes. Okay, so this is plus pi k.
The element of the reals, does the R have to be that special way?
Yeah, it's got to be the funky, like
diagram.
Kind of. I mean, it's like R, and then you just draw another one of those. Okay. Just wait till we talk about integers. They are like that. It's like this weird, kind of like Zorro. We don't have to worry about that right now. Okay. All right. Questions on cosecant? 2 pi over b. So for the parent graph, it's going to be 2 pi. All right. Turn the page. Yo, yes.
You said the zero changes. I didn't really get some stress.
Like where the asymptotes would be? Yeah. So if this shifts up or down, it's still. Do you see how these are on your midline? Those asymptotes are still going to go through the midline. Like even if it moves up or down, from the top of your sine graph it goes up. From the bottom it goes down. In the middle, midline gives you asymptotes.
Oh, it's in zero.
I mean in the domain.
Oh, in the domain. So graph secant, and then we'll talk about it. Yes.
So you said when it moves across the midline, the asymptotes
like-
are still where it touches the x-axis, right?
No. So what if? Here, squeeze it in. So, like, let's say. Okay. You could graph. Here's sine, right? I'm going to go down. So it's now 1, 2, 3. Right? Like that's the sine graph. So if I wanted to make that cosecant, nothing's on the x-axis, right?
Right.
But these midline points are where the asymptotes are, and then from here it's going up, and from here.
So the asymptotes are always going to be where the midline is.
Yes. All right, guys, try to graph secant. So turn the page. Just like we did with this one, graph cosine first. Label everything. Try to turn it into secant. Just find it. Okay. Where is your calculator from? I'll give you a minute to think.
No, wait. The half part. X is not equal. Okay. 1 pi over 2 plus pi k. But what about the ends?
Oh, you get like little half breaths. Yeah.
That format for element of the wheels and I've never seen it like in Master. But like I've seen it on problems.
You're supposed to learn that I don't think it's emphasized very much. Where an asymptote is, and then how far.
Better not have some
Yeah.
She'll rest the guys. Yeah, she'll rest the guys.
Like you just know the term.
Yeah. But it'll be the same way too.
Get over it.
You don't really hit though.
You make me like put my fingers like something wrong. It wasn't that.
I did not hear all of that.
It only actually.
Are you guys ready to see it?
Yeah.
Yeah?
Yeah.
Ah. Guys, your domain, how'd you do? X such that X is an element of the reals, that X cannot equal pi over 2 plus pi k. So my labeling here, what this is talking about, the first piece is where's your, I say first asymptote, but really any asymptote. And then how far to the next asymptote? How far apart are they?
Wait, you can put any asymptote there?
You could.
So you could do like 101 billion pi over 2.
Sure. Well, you gotta make sure that it's not, yeah, it can't be even.
And it would be perfectly fine.
You can do that, kid.
Literally following would be that kid.
Yeah, you
Write 3 pages of digits. But then you just go to the last page and look at the last one to see if it's on.
yeah. Yeah, don't mess that up. Alright guys, questions on it?
So I'd have to make an addition problem. So that it would add up to an odd number, but it'd be like really, really long.
Alright, are we ready for tangent and cotangent? Oh, before we go on, something important with this. Okay, this graph does not have amplitude. Secant and cosecant do not have amplitude. You can certainly stretch them vertically, but amplitude talks about the height of the graph. Why do you think this doesn't actually have a height? It goes to infinity, yeah. So can you really figure out the height if it goes all the way to infinity? And is that really what A is going to stand for? Half infinity?
Oh, I know what you mean. Okay.
Okay. So, secant and cosecant and secant do not have amplitude. So don't let me trick you on a quiz or a test question. If I say, what's the amplitude? None. Like these. Okay. Does that make sense to everybody? Okay. All right, tangent and cotangent. We get to graph those next. I know, both together, they're kind of small.
And that's y over x, that's where x is.
Okay, so tangent. Tangent is sine over cosine, or we thought of it as y over x on our circle. So let's start over here at 0 radians or 0 degrees. What is tangent going to be? Your order pair is 1, 0.
Zero.
Zero.
Ah, okay, which is it?
Zero.
Wait. Zero.
Zero.
What is
Zero. Zero.
It is 0, yes. You have that dot. I'm not going to fill in the table. If you want it there, you go for it. Okay, the next spot I'm going to go to with tangent, I'm not going to go all the way to pi over 2 yet. I'm going to go to pi over 4. Why do you think I've picked pi over 4? Because the tangent is 1. That's pretty simple. And it gives me some idea of where I'm going. So that's 1. All right, then I can keep going to pi over 2. So up here, what is the tangent when I'm up there at 0, 1? Undefined. So what's that going to be? Asymptote. Okay. Where do you think I'm going next? 3 pi over 4. And what is it there? Somebody said? Negative 1. Okay, good. And the last spot I'm going to is pi. And what will that be? 0. Good. Okay, I want to know what's happening on the left side of this graph too. Because it's undefined? 1 over 0? Yes, okay. All right, I want to go over here to negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. What do you think those are going to be doing? What do you think negative pi over 4 is going to be? Negative 1. What about negative pi over 2? Asymptote, yep. Negative 3 pi over 4? 1. And negative pi. Okay, so let's look at thing we have here. Okay, when you sketch the shape of this, it's kind of like a cube, yeah. I find that this is the one that's hardest for you guys to draw. One way to think about it, think of this concave up, right? And this concave down. So if you need to like draw it in 2 pieces and then connect them, you can. But it does change concavity right there at the midline. Okay? Questions on tangent? Okay, try to graph cotangent. And then we'll talk about domain, range, period, all of that stuff together at the end. Got like 4 minutes. Cotangent, x over y. You're going to be doing the same pi over 4, pi over 2, all of that. Oh dear. I don't know what I'm doing. Actually, never about this. I'm just going to grab it. And label. Just work on the shape. You kind of have to do these more.
Should have done something.
Yeah.
No, it goes. I just did it. I pushed it out. Yeah. Yeah. So would they? Like.
Don't make them too squiggly, okay? They're not like little worms on your paper. Beautiful. Yay. All right, guys, go to lunch. We'll go over it after lunch, I promise. All right, guys, let's look at cotangent. Okay, guys, let's figure out how to do it.
So that's
Yeah, guys, you can go through thinking about cotangent on your circle, or I heard some of you saying, well, it's the reciprocal of this one. So where this one's 0 is where you're going to have an asymptote. 1 is 1, -1 is -1. You can think of it that way. Questions on the actual graph? Do you need a minute to see if you can pull right in here? Yeah, I think that's
Something about it.
Okay, guys, once you have the graphs done, let's look at it to figure out the domain range and period. So the period, let's look at cotangent here. Do you agree that between the two asymptotes you're seeing the entire graph? Okay, so what do you think the period is? Pi, and it's the same for tangent, okay? After pi, it's going to start repeating. So the period for these two are both pi over b. What if you... All right, what's the range for both of them? Okay, domain. I feel like there's not really enough room here for tangents. Let's see. X, such that X is an element of the reals, but X cannot equal... For tangent, what would you say? Where's an asymptote? pi over 2 plus, how far apart are they? Are they pi or pi over 2? It's pi. Yeah. Distance between asymptotes. Negative pi over 2 to positive pi over 2. That's a length of pi. So plus pi k. So for cotangent then, it's going to be x, such that x is an element of the reals, but x cannot equal 0 plus pi k. That works. If you just told me pi k, that's fine too. Okay. What do you think? Do these have amplitude? No. Why? You're right. Yeah, it goes to infinity, okay? You can stretch them, but they don't actually have a defined amplitude, okay? All right. Let's turn the page and try to graph it. All right, so the first one here, y equals cosecant of 2x. I'm going to start by graphing y equals sine of 2x. What do I do? Label. What am I going to label the x-axis as? The period is pi, yes.
Can we do it where one side is like the parent and then the other side is the other, the cosecant graph? So that way they don't overlap.
What if I ask you to graph 2 periods of it?
Then,
Okay.
unless one side's really long.
How would you really extend your graph? Okay, guys, so sine parent graph, we know, right? 0, 1, 0, 0. And completely up to you. If you don't want to connect that, like if you don't want to see the sine graph on there, that's fine. You can just take those dots and draw what you need to for cosecant. Yeah.
When asked to graph for like a test or quiz, and if you draw the sine graph, you have to like kind of erase it or make it dotted, or can it be full line?
You can leave it fully connected. I would. This is where like having colors or a pen and a pencil might help, because then you could be like, okay, the pencil's my parent graph. Like I don't need that anymore. Only look at pen or the blue or whatever color.
And should we make it obvious that we need to use that cosecant rather than?
Yeah. Like so, just in some way, note for me what you're doing. Okay. Like for me, I'm gonna have my answer here in blue. Okay. And again, you can draw the sine graph. I don't care. I'm just not. Nothing wrong with drawing it. Pretty simple? Yeah, okay. All right, so number 2, this is 3 tangent. Okay, so the 3, it's not amplitude, but what does it do? Stretches it, yeah. Let me label some things. There's not a ton of room on here vertically, so I'm gonna call that 1, 2, 3, just so we can see some more tick marks here. And then x-axis, I'm going to do the pi over 4, pi over 2, 3 pi over 4, and pi, right? Because there was no period change with this. Make sense? Okay. So tangent, that's the one that starts at 0. And then at pi over 4, instead of being at 1, where is this dot going to be? 3. Yeah, it's just getting stretched out vertically. Pi over 2 is still an asymptote. Then instead of -1, I'm going to be at -3, 0. All right, are we okay on number 2? If I go too fast, just stop me, okay? I've changed number 3. I added a -1 to the end. Okay. Phone's away, guys. All right, I'm going to graph this first as if it is cosine. So I'm really thinking about negative cosine of x minus pi over 2 minus 1. Has there been a period change in this one? Nope. So back to the labels of pi over 2, pi, 3 pi over 2, and 2 pi. I'm going to go ahead and do the negative and cosine first, and then I'll do the shifting of the points after that. Sure. Do you guys have questions on 2 or? Okay. Oh, okay. So on 3, guys, I've got those dots. All I've done is basically flip cosine. Where am I shifting each of these points then? Yes. So to the right pi over 2 and down 1, which is diagonal, right? So that's 1 tick mark over, 1 tick mark down. Draw it in just so you can see it because there's a lot of dots happening there. So then to actually make it secant, where are the asymptotes going to be? Yes. They're still through those midline points, guys. Okay? It's not what's on the x-axis now, it's what used to be on the x-axis. Those middle points give you asymptotes. And then from the minimum values, you go down. From the maximum values, you go up. So again, blue is my final answer. Does that make sense with the shifting, how those asymptotes still work? Questions on any of these, guys? Okay, what I want you to work on now, with a partner in a group, you're going to go ahead and try to do these next 4 problems. So for 4 and 5, you are writing the equations of these graphs, and it says you can write 2 equations. So like for number 4, you could write it as tangent, or you could write it as cotangent. How would that be cotangent? Yeah, negative and front flipping it, okay? So 5, you could write as secant or cosecant. And then 6 and 7, you've got to try to graph these. Those really are not too bad because you can think of it as sine or cosine. Okay. All right, so guys, go ahead and get to work on these. The obvious one is tangent, like that's the page you want though. There is one over here. Okay, you can write it as tangent or as cosecant.
Okay, I was like,
I know, your brain immediately is tangent. What else? Yeah. Just like sine and cosine, same. But they are, they're because you see other systems.
maybe the times
I will give you time to think on these, okay?
I think you probably did it right. I agree. No, but then how do you make it? This is one
Oh yeah. For the first debate, it's fine.
I got one now. Their x plus negative 5. Might be just pi over plus 2.
I don't know. You're probably right. I don't know.
Anywhere between like the 2 and 4.
Where the midline is.
Because the difference between A and B is 3 pi over 3 and B pi over 4, so it's 3 times smaller.
Because one's negative, one's positive. What's the difference being? You subtract it, so it'd be 6 pi over 4.
Here, the whole thing needs to end at 2 pi. Like you need to have.
Because it's negative and positive. Between them, you're not subtracting negative.
Basically, this is half. So the scale is 4 times. Here is 4 times. No, he's right.
So you're thinking in between, right? My idea is that this Okay, wait, the distance between A and C is 300 with radius. And then if you take that A and C return, this is half pi, right? Times no, but total distance. That's the total you receive. Total distance is this is pi over 4, right? When it's half, right? So if we pretend that pi over 4 is minus pi. So the distance between those two is pi over here, right? And then put up a ratio of 3 pi over 2. It's like it's being stretched by 3. Right?
Oh, sorry. You just
So this one would be negative pi over
sorry, that's side shifted pi.
I mean, it's only things that's opposite. The period here is pi, and the period on the other one. So this would be 6 times 1. Yeah. Then that would be 6. Multiply that by 2. That's only half. Right? This here is still fine. 1, 2, 3, 1, 2. Because it's in chunks. No, this is yeah.
Yeah, those are easier than the bottom two are easier than the top two ones.
Yeah. Between A and C, one of the problems is half of it, so then you can do 5
Okay.
This is the word. So the distance from here to your is 3 by 5 over 2. Then you add 2 again up to there because it would normally be 0, 0, so now it's there. Now distance would be this has to be, so when you're saying 3 times that, this has to be yeah.
I would have love that, but that's okay.
Then you know that this is the amount that you can going up. It's 5, so that's 1/2. So then that increases by 2 pi over the right?
You're trying to check that here.
Like, point B makes sense, but the other thing is fine. Oh, that's right. I forgot. So then it's
I Alright guys, your homework. We're going to go over these 4 next time in your packet. There's a sheet that says classwork. You are not doing that right now, okay? The only page you are doing is this. There is no back. So just the front. Now, if you look at it, you're filling in like the different shifts, the directions, all that, period, domain, range. And then I'm going to ask you to pick 5 of them to graph. You graph whatever 5 you want. You can just do it on the back. Just make sketches of them, okay? Make sense? Yes, we're all over graph 5, okay? All right, guys, have a good day.
Hey, ready to leave for our fathers or something? Oh, are you going to